Sunlight slants through leaf litter. A speck lifts itself on stilted legs and freezes. Then the performance starts. Forelegs flick in staccato beats. The abdomen fans open like a lacquered fan, then tilts a fraction to catch the light. Iridescence ignites, then shifts with each step. The ground vibrates with faint drumming the eye cannot see, but the watcher can feel. This is a jumping spider mating dance within the strike zone of risk, where a wrong note can turn the stage into a trap. In a world measured in millimeters, a tiny arachnid with a Technicolor show wagers everything on timing. Across open heath and eucalyptus leaf beds in southern Australia, hunters with oversized eyes track prey by sight. They do not cast capture webs. They stalk, leap, and subdue with speed and geometry. Vision rules, especially for those forward-facing lenses that judge distance and color with uncommon precision for an arthropod. Males advertise, females evaluate. The show blends motion, vibration, and light into one signal. When the abdomen lifts and flares, panels and hairs catch sunbeams and bend them into saturated hues. The stakes are immediate. Acceptance leads to mating. Rejection can be fatal. Only then does the name fit the spectacle. Peacock spider dance, an anchor for the rarest kind of display, where beauty is function carved by selection. The puzzle sits at the heart of that beauty. How do such small creatures produce and control such vibrant structural colors? Bodies run 3 to 6 millimeters long, yet their displays rival feathers and beetle shells. Evidence suggests scales on the abdomen form microscopic arrays, ridges, layers, and lattices carved from chitin and air. Spacing within hundreds of nanometers matches wavelengths of blue, green, and red, turning white light into narrow band flashes. When the performer tilts the abdomen or twitches a leg, the hue shifts, because angle changes the path of light through those nanoscale stacks. In peacock spider courtship, these shifts synchronize with substrate-born songs from rapid abdominal tremors, sometimes dozens of pulses per second. The female's eyes, tuned to color and motion, pass the package: rhythm, brightness, and direction. The constraint is brutal. Surface dust, a wrong angle, or a shadow can dull the signal. Yet peacock spider colors cut through clutter with intensity that seems impossible to explain at this scale. A misread step and the dancer can be seized. A perfect cadence and a lineage continues. 3 lines of explanation dominate. First, structural engineering in miniature. Studies indicate many Maratus spider scales act like multi-layer reflectors and diffraction gratings. Layers of chitin separated by air reflect specific wavelengths through thin film interference, while nanoscale grooves split light into angular rainbows. The animal controls output by posture. Raising the abdomen changes incidence. Lateral sways scan the beam across the female's gaze. The trade-off is fragility and cost. Building precise nanostructures demands development time and materials. Damage can break the optical effect. Still, the payoff is bright color without pigment, immune to fading with age. Second, contrast management. Patches of velvet black cut next to iridescent panels. Microcavities and tangled hairs trap light, producing super black that erases glare. Against that abyss, peacock spider colors appear brighter than their physics alone would allow. This contrast heightens leg waves, abdomen flicks, and the sideways slides that define arachnid display behavior. The limit surfaces in dim light or under cloud. Without sun to strike those gratings, intensity falls, and the male leans harder on vibration. Third, multimodal redundancy. The display merges vision and tremor. A jumping spider mating dance does not just show. It also plays through the ground. Vibrations travel through leaf and twig, arriving even when line of sight breaks. Evidence suggests females weight both channels and penalize mismatches. That redundancy stabilizes courtship in a gusty, cluttered habitat. The cost is time exposed to predators and to the female herself. A false move can end with the dancer vanished between her chelicerae. Scientists still debate how developmental pathways specify such fine optical textures and whether temperature or diet nudge those patterns during growth. The blueprint remains partly untraceable. Scale adds another layer. Some Maratus spider species deploy fans with flaps that hinge outward, widening the display. Others paint with different palettes, shifting the order of moves so colors strike in sequence. Why one lineage favors blues and another burns with orange is not fully resolved. Sexual selection can chase novelty. Predators can prune the gaudy excess. Meanwhile, peacock spider courtship persists as a tightrope act. Conspicuous enough to win, restrained enough to survive. The choreography puts constraints to work. Angle, sun height, background. So peacock spider colors read cleanly at female viewing distances of a few centimeters. The tuning may be local. Populations separated by scrub and sand often diverge in pattern and step, rewriting what we thought we knew about how fast ornament can evolve in a small arachnid. The performance narrows again to a clearing. The fan rises, legs describe a figure eight. The abdomen ticks in microscopic degrees. A breath of wind dulls the sheen, then the cloud moves and the panels blaze back alive. For a beat, the signal, the song, and the stance lock. The decision arrives with a lean forward or a lunge. Can a dance save your life? In this arena, the answer is yes, but never guaranteed. Peacock spider dance. The tiny arachnid with a Technicolor show endures as long as selection keeps its physics aligned with sky and leaf. If seasons shift or shadows lengthen, the rules may tilt, and the light that made this courtship sing could dim to gray before anyone notices it has gone.